Okay, so Assalamualaikum. So kita going to do the question on verify Green's theorem. Okay, given that line integral to xy dx plus y dy refer to the curve C, where C is the boundary of region lying between the graph of y equals to 0 and y equals to 4 minus x squared. Okay, from the point negative 2, 0 to 2, 0, then along the curve y equals to 4 minus x square, and then back to the point negative 2, 0. Okay, this is past year question. So for this question, it's involved 10 marks. Okay, so for the first step that you need to know is you have to draw the diagram. Okay, step 1. Step 1. So refer to the question from the point negative 0 to 0 to 0, then along the curve y equals to 4 minus x squared, then back to the point negative 0. Okay, from there we can just draw the graph. Okay, okay, so roughly this is negative 2, this is 2. Okay, so this is the curve y. Okay, here will be 4. Okay, when x equals to 0, y equals to 4. Okay, so from the point negative to 0, so that means negative to 2, and then along the curve y equals to 4 minus x squared, back to the point, same point, negative 2. Okay, so you have this arrow. Okay, so this is the region R. Okay, between the graph y equals to 0, this is graph 9y equals to 0. Okay, so meaning that the Green's theorem is given by the equation f vector dot dr vector, so is equals to double integral qx minus py dA. Okay, so refer to the region R. Okay, how do we get this qx minus py? So actually from vector f dot dr is equals to p dx minus q plus q dy. So you have to differentiate with respect to you get qx, and differentiate py, differentiate p with respect to y. Okay, so we need to, if they say verify Green's theorem, so meaning that you have to show left hand side is equals to right hand side. Okay, so that means you need to show the solution here and both solution. Okay, what you have to do is you do the first step for then the next one will be the second one. step A and step B. Okay. Okay, now what we have to do is we do the step A. Okay, step A. Second step, what you have to do is use Green's theorem. F dot dr is given by 2xy dx plus x plus y dy. Okay, so meaning this part will be B, this is Q. Okay, so P equals to 2xy, so you need to find Px. Differentiate P with respect to x is equals to 2y1, so you get 2y. So Q, oh no, this is supposed to be y. So you need to find Py is 2x1 is 2. Okay, so it's actually dy. Okay, Q is x plus y. So meaning that you have to find the differentiate Q with respect to x. So it's Qx. So it's 1. Okay, so meaning that here will be double integral Qx minus Py dy. So that will be 1 minus 2x dA. So you have to refer to the region to determine the limit. Okay. Okay, so what is the value? So we named here is step 4, step E. Okay, so step 2, determine the region R. Okay, so we go back to see the diagram. Negative 2, 2. So we have 4 here. So this is y equals to 4 minus x squared. So this is x, this is y. So this is y equals to 0. So this is the area R. Region R. Okay, so just now double 1 minus 2x dA, so is equals to it is equals to, you have to decide the dA from the region dx dy or dy dx. Okay, so we use the cross section vertical. Okay, meaning that we will use so the initial point will be on y equals to 0, and then terminal point will be on y equals to x squared. So 1 minus 2x, we choose dy dx. Okay, so the value of x will be x equals to negative 2 to 2. Okay, so if you solve the equation, the integral, so you will get the answer of 32 over 3. Okay, okay, so next you have to do the right hand side. So step 3, left hand side, that means is step B. Okay, so right hand side will be using the line integral. Okay, so here we'll be use stock theorem. I use a Green's theorem. So that means you need to use the double integral. Okay, so the line integral f dot dr is given by 2xy dx plus x plus y dy. Okay, so we refer to the same diagram. So negative 2, 0. This is point 20. So we have here is y equals 4 minus x squared. So x, y. So we have here two curves. One will be curve 1. Here will be curve 2. Okay. So meaning that curve 2xy dx plus x plus y dy equals to 2xy dx plus x plus y dy for curve 1 plus with 2xy dx plus x plus y dy curve 2. Okay, meaning that we need to show for each curve. Okay, so step B will be curve 1 dy. So curve 1, okay, along curve 1, equation involved is given by y equals to 0. Okay, we have here the line is y equals to 0. Okay, so therefore the derivative y will be 0. So C1 2xy dx plus x plus y dy. So here will be 0, here will be 0. So we get 0. Okay, that is step B. Step C, curve 2, 2xy dx plus x plus y dy. So along curve 2, meaning the equation involved is y equals to 4 minus x squared. So take the derivative dy dx, you get negative 2x, meaning that dy equals to negative 2x dx. Okay? Okay, so C2 2xy dx plus x plus y dy. So along, so we substitute into the y and also dy. Okay, so y equals to 4 minus x squared, so dy will be uh, negative, dy will be negative 2x dx. Okay, so curve to 2x 4 minus x squared plus x plus 4 minus x squared dy is negative 2x dx. Okay, so curve to 8x minus 2x squared plus negative 2x negative x plus 2x cubed dx. Okay, so this one you can cancel off. Okay, so cube, this one you can cancel off, so negative 2x squared. So C2 negative 2x squared dx. Okay, so it should be point. Okay, the point will be point here 2 0 2 along the curve. The last the terminal point will be negative 0. Okay, so that means we start with 2 0 and then negative 2 0 into x squared dx. Okay, so when you, because of the variable x, so we will choose value x. Okay, so we get negative 2 to negative 2x squared dx. So when you try to get the integral, you should get 32 over 3. Okay, so this will be for right hand side. Okay, so we go back and see the question. So let this step will be step A, and then we do for step B. Okay, so this is for, so this is for step 1 or step 2. Okay, left hand side. And we have the P. So the final answer will be right hand side, left hand side. Is equals to right hand side. So therefore, Green's theorem is verified. Okay. Okay, so you can do question 4 tutorial. Okay, question on verify Green's theorem. Okay, 32. They split into 2, so A will be directly without using Green's theorem, meaning that you need to use line integral. Okay, if by using Green's theorem, so you need to use double integral. Okay, which refer to the region R, this one refer to the